I think they make them all work for you, yes.
I'm a tech guy, so if there's a tech guy, there's always a problem with the technology. You should, if you want to have some fun, and let's have a little fun before we start this, When there's a problem with the beamer, you get all of the engineers together, and we'll figure out how to do it in a day. Anyway, so I'd like to start that we're going to discuss smart cities. And smart cities are critical to mitigating and solving our climate crisis. Okay, can we accept that? Oh, and with further ado, I'd like to introduce my partner on the stage tonight. Sebastian, please come up and join us. So we're going to take you on a little journey. We're going to explain smart cities. We're going to go into hydrogen generation. We're going to examine a city in Japan that is doing this right now. And then we're going to discuss the IoT infrastructure that's needed to realize a smart city. Let's get some common definitions because this helps, and this will help frame what we're going to discuss. So, and is that the right slide? Okay. Sometimes slides, I misposition them because that's supposed to be the end, but I don't need to look at the slides. So what we're going to define is, what is a smart city? We're talking about a city that has a computational element in order to manage goods and services and the operation of the city, okay? And then hydrogen generation, that's where Enapter comes in, right? Decentralized energy. And then we're going to discuss Kobe, smart city, where it's a smart city with hydrogen power, right? And then at the end, we have an IoT fabric that stitches all of this together. And we're going to use it as an example, a company from Berlin called Stax. Now, you may be wondering why IoT hasn't taken off on the planet. Those of you that work in the industry like me, know it's painful. And this company, Stax in Berlin, has found a way to make IoT deployments less painful and energy efficient. We'll drill into that. Well, there's the definitions I have. So forgive me, sometimes we make mistakes with slides. But anyway, you can look at that. We're defining climate change, green hydrogen, smart city, and IoT. And let me give you, I love this definition of IoT. Forget all the complexity. It's just digital physical, right? And just keep that in your mind as we progress. What's the problem statement? Thank you, McKinsey. A piece of advice, when you're putting together these slide decks, if you have a friend from McKinsey, it's really helpful. They have the best graphics. But why are smart cities critical to the solutions for climate change? Look at the numbers right here, right? 2/3 of the world's energy is consumed by cities. So what are we going to do about that? Think of how much carbon is generated. Cities are the problem. Yet at the same time, innovation comes from the cities. So what are we going to do? Are we going to shut the cities down because we have a carbon problem? Or are we going to adapt and do something new? Are we going to use new technologies in order to solve our climate problems? But now I'm going to hand this to Sebastian because we want to give you a vision of the future. And we're going to start with this beautiful house. And Sebastian.
Yeah. Okay, green is next. In 2014, I was developing a new home for the family of the Schmidt family. And it's in northern Thailand, called Pisuo House. You can find it also on this link below. No, on the app. We built actually this house with hydrogen, with a hydrogen storage, which was actually a surprise for us that we were the first home actually building and using hydrogen as a storage. If I would know it before, maybe I would not buy it, but the people who sold me the system, Italians, told me that these kind of systems are almost everywhere in the world. So we bought prototypes with the serial number 8, 9, 10, and 11, and experimented for several years with this until this company went bankrupt in 2017, and we acquired the company. Meanwhile, it looks a little bit different. So you see on the right side the history of electrolyzer from the one I bought on the left side, the two boxes. Then you see that they become more and more compact. And by end of this year, we will bring the model 4.0 on the market. We call it 4.0 because of IoT 4.0, Industry 4.0, this kind of fully automated fully packed with sensors. We already have in this 2.1, which is our system today, more than 30 sensors and OTA, so over the air. So like we do all this firmware updates remotely. So today we have 1,600 devices delivered, more than 160 customers around the world, and a huge demand for the future because we believe that scalable electrolyzers are the future. This is the factory what we are building in Saarbeck. The groundbreaking happened 2 weeks ago. So starting mid of next year, we will start building electrolyzers on this side. End of 2022, it will be fully operational. At the moment, we are producing in Italy. We have around 6,000 square meter production and R&D area. Most of our companies, most of our employees, of the 180 people we have today, are in R&D. So why we believe actually that electrolyzer will change to the good in our world, because decarbonization module hydrogen will help a lot to change. It is not only needed for electric power, it's also used in many ways. So we have customers producing industrial feedstock. One of our American customer, he used hydrogen to feed bacteria, and they produce the food of the future when we cannot produce it anymore on outside. Heating and cooling is very strong, so quite a lot of projects in Netherlands with heating. We see a lot of new use cases, ammonia production, methane production, so quite a lot of chemical welding topics, cleaning. So there's quite a lot of hydrogen used today, and which is gray, means that has CO2, and we are working with all the other electrolyzer companies together on decarbonization of the world. Yeah, why scalable? So you saw that our system is so small. Is it the right idea? We believe this is actually the right idea, because if you have the idea to break the system, then you need disruptive ideas. And our disruptive idea is to make it mass producible. We have a different technology. We're using IEM technology instead of PEM, what you hear quite often. So this actually helps us to reduce noble metals. For example, we don't use any titanium in our stacks. The biggest cost driver in electrolyzers today is titanium. We don't need titanium. This is the reason why we get our price down. Our aim is to reach €1.50 per kilogram by end of hydrogen by end of 2022. So you see that we build containers, and this is, let's say, the platform strategy and platform aspects. We are at the moment quite. If you search for us, then you will find quite a lot. Endless opportunities. I already talked about this. I think maybe we have time for later for questions. I'll go into these kind of points later. One of the biggest issue what we always talked about, and here the typical energy players never follow us. We speak about disruption through infrastructure. We believe that producing on site where the energy is will help a lot. When we see our problems, what we have today in Germany or all over the world, then you will see quite a lot of, let's say, situations where new energy systems, electric energy systems has to be built, new transmission lines has to be done in Germany. When you see the time, how actually it will take, how long it will take to build these kind of new transmission lines, then the energy transition is already, let's say, over, so the time. So we need, let's say, even for the simple process of getting permission, more than 10 years. So building time, another 10 years. So I don't believe that this is the right way. So we are pushing towards decentralization. This will also help some of the biggest, to address the biggest problem in the world. I mean, we still have quite a lot of people in the world who have no energy at all, no access to energy, because energy storage is a problem. Not the energy, getting energy. Today, solar and wind is the cheapest way to produce energy, cheaper than every other means of producing energy. However, storing is important, and we believe that hydrogen will be the missing piece in the energy field. Yeah, okay, so, and this is my last slide, I think. It's about investment. This is only to understand where the investment goes today. So we hear a lot about green energy, but technical-wise, the most investment in energy is done actually in oil and gas, even today, and in a quite big number. So this is arena numbers, so you can find them public way as well. Thank you.
Thank you so much, Sebastian. Really appreciate it. Oh yeah, I get the clicker now. So now we've got an idea of a piece of technology, electrolyzers from a naptor, to help solve the problem of hydrogen generation in a distributed fashion. But what is this going to look like? We see a beautiful house, the Pisuo House, and definitely you can ping Sebastian. He likes visitors, but you need to bring special sand from a beach. Well, we can answer that in questions, okay? But let's go. What does it look like in a big city? How are we going to do this? Do we have an example on the planet to follow? Yes. As a matter of fact, we do. So we have this smart city project with Kobe in Japan that we are working with. And this is a smart city powered by hydrogen. So see the vision that Sebastian had, scale it up to a city, and that is Kobe. This is not science fiction. It exists right now. So something about Kobe, what I'd like to share about the smart city before we go to the next slide, is that they have adopted this bottom-up approach to work with the municipality, that it is not being driven by the city government imposing on the people. The city government provides a platform for the citizens to engage, so the solutions come from the bottom up. And in fact, the Kobe Smart City project is executed so well that it has become a model for the country of Japan, and other cities are adopting what Kobe has done. So we've established that this city has the IT infrastructure they're building in order to have a smart city. They have smart people building this smart city, and they have hydrogen, okay, as an energy store. What does that look like? This is a hydrogen terminal. This is the future, right? Think of these terminals without liquefied natural gas or petroleum products. Think of these terminals filled with hydrogen created from electrolyzers such as adapters, okay? So this is, I think this was Kawasaki Heavy Industries that made this. Okay, so this is not photoshopped. It's operating right now. And for any of you in the engineering realm, think about what it takes to transport liquid hydrogen. And I'm sure we're going to learn a lot from the country of Japan because they're masters in this. Now, this may seem irrelevant, but this is an illustration of smart cities. And this is something that Kobe is doing. It links to hydrogen because HVAC, heating, venting, and air conditioning systems require energy. So what Kobe's doing, right? We have this whole energy infrastructure. This is important because when you make a smart city, you get multiple beautiful things that happen. This is airflow. We're living in a time of COVID, so we're all painfully aware of how bad airflow contributes to super spreader events. Before COVID, bad airflow is why when you'd ride that metro bus, you got sick with the cold. So Kobe recognizes this and is using the smart city infrastructure to tackle this problem, people and airflow. What does this mean? Improved health. It means that, you know, when your kids go back to school and you all bring home that cold, this is a way you avoid that by changing the environment, by having a smart infrastructure. And the only way you can track is to have a smart city. So we can learn a lot from Kobe. The hydrogen that they have in Kobe will power systems like this in a sustainable manner. However, if you want to learn more, I urge you to come to the panels and the discussions this Thursday. So not tomorrow, that's Wednesday, that's Investor Day, and I urge you to come here for that as well. But Thursday, if you have deep questions about Kobe, Japan, co-creating smart cities, please join our event. Okay, now let's get to the computational layer. And forgive me if I get a little geeky, but hey, this is a lot of fun, and this is where I'm really going to have a lot of fun. So, IoT and smart cities, right? Do we have any successful deployments of smart cities? Yeah, but they're kind of hard. We can look at Songdo in Korea, amazing. But why aren't we just popping up smart cities everywhere? Because they're complex. It's a heterogeneous environment. I mean, if you wanted to define tricky, devilishly tricky, heterogeneous environments, that's a city, okay? It's a nightmare, or it's an opportunity. If you have the right software tools, it's an opportunity. But I'd like to add this. You see the text here, right? Why am I throwing out this like non sequitur that if the internet was a country, it would be number 6 on energy generation consumption? Because smart cities require internet and computation, and we'll get to that solution later. So how does this stacks work? And why am I pushing for stacks? Because the failure to adopt IoT efficiently in order to create smart cities is an IoT deployment problem, okay? And we need new technologies. So what this company Stacks does, this is not traditional. You don't have this central cloud where you register all of your devices. And believe me, if any of you have had to try to build IoT systems and register with Azure Cloud or Amazon, it's a good way to learn profanities because it can become very, very difficult and takes a lot of time. You have to spend more time on plumbing than constructing this solution. So what Stacks does is this is decentralized. That's what I want you to know, that instead of going to a cloud, Stacks leverages all of these smart nodes that we have in a city, all of this excess computational power. Why am I sending data to the cloud to process when I have millions of smart devices with a lot of excess computational power? So here's how, Stacks, I really appreciate your contribution because they've been doing research on how you would use their tools to implement a smart city, right? We've got different layers here. We have different user layers, municipalities, companies, any grouping. And we have edge devices. You see, that's the key to making IoT ubiquitous and smart cities. You've got to use the edge, as I was mentioning. So how are we really going to enable this? Do you see all of this cross-communication? With standard systems that we have right now, this is a plumbing and management nightmare. However, with Stacks, it's decentralized. But we're going to we'll have a little bit more to share. It's not just decentralized. You need to have blockchain. Why? How are you going to track everything that's going on in a smart city? How are you going to maintain control over 1 million devices, right? You can't have a person. You need to have smart contracts. You're going to need to have blockchain to identify the device, to connect nodes creatively. And that's what Stacks can do. But also, when we implement this decentralized hydrogen infrastructure, right? Instead of building new power lines, we can use IT tools such as Stacks and put sensors along the entire value chain for hydrogen in order to manage. So, to wrap this up, right? I think I got the slide, I got it positioned right. If we want to solve climate change, the key is smart cities. And Anapter's right here to create technology. I mean, they have the technology for creating green hydrogen. How do we do it? Just ask Kobe. We've got a city to follow. Isn't that beautiful? But what are we going to do with all this IoT infrastructure? Do we need to spin up another platform? Do we need to hire more administrators for Azure or AWS? No. Why don't you check out this company called Stacks, born in Berlin, that has a working solution. And on that, are there any questions? Okay. Are we good?